Hello, my Calc 2 student. I hope our semester got well, and today we talk about logarithmic and exponential function with other than e basic, and this is section 5.5. But first we prepare. Okay, first let's go. We have some a to the power x. Use logarithmic or exponential identity. I can rewrite this as e to the ln a to the power x, because it's composite two inverse function. It will be a to the power x. Okay, a to the exponent x. But we continue use logarithmic identity, and I can rewrite like a to the ln a like coefficient times x. Something similar we have for logarithmic function. This means if you have log with base a from x, use identity for change base. You can write as like ln x divided by ln a. Any situation, ln a is only some constant coefficient. Use this two identity. We can easily see theorem. Let's go theorem 1. Who tell us derivative for exponential function a to the exponent x. It will be, it's like we take it derivative for this kind of function. It will be, and use this fact, we have ln a times a to the power x. This is a. If your variable is not a simple variable but some function, then let's take a derivative for a to the power u. It will be, use chain rule, u prime. Believe me, here is u prime. Okay. A, B, C. What happened if I have, if I take a derivative for a logarithmic function? This will be d for dx logarithmic to the power x. This will be 1 over x times ln a. And last formula, d for dx from logarithmic. If you have some function here, it will be u prime over u ln a. Well, try to prove something. I think if you're proving a and c, this means automatically prove b and z, because b and z coming from a and c and chain rule. Okay, proof. A exponent x, take a derivative. We remember about our identity. This means this will be e to the ln a times x. Take derivative. It will be, here is exponential function with base e. This means derivative, it will be same function ln a multiplied by derivative exponent. But derivative exponent is coefficient multiplied by x. This means exactly coefficient ln a. If we go back and use our identity one more time, it will be a to the power x times ln a. Exactly what we need to prove. Remember, we prove a, formula a. Formula b is formula a and chain rule. What about c? we need to take a derivative for log base a from x. It will be use identity we have ln x over ln a. Take derivative we have 1 over x. Ln a, this situation is only constant. This means still stay here. It will be 1 over x times ln a. Okay. One more theorem. Well, because we now have found derivative, this means we can find integral. And here's theorem number 2. To tell us integral for a exponent x dx will be 1 over ln a exponent x plus c. Well, here we don't need to prove anything because we only use our formula a from first theorem and that's it. Okay, great. Doing some example. Examples. First we take it something simple. For example, found derivative function 2 to the power 3x. This is exponential function, base is 2, power is 3x, exponent is 3x. This means derivative it will be. How you remember? It will be natural log with base, this means 2, multiplied by same function, 2 to the power 3x, and multiplied by derivative, our exponent, derivative, our power, with 3. This means here we have 2 to the power 3x times 3 ln 2. Okay. This is question A. Example A. Example B. We have, let's go, we have logarithmic function. Logarithmic function with base 5 from cosine 4x. How you remember? Logarithmic function derivative will be 1 over natural log your base, this means 5, then fraction where you have what you have inside your logarithm go to denominator, cosine 4x, and numerical it will be derivative your denominator, this means, or derivative function who stay inside logarithm. Derivative cosine is negative sign because it's cosine 4x, this means negative 4 sine 4x. This means here we have, if you simplify, we have minus 4 over ln 5 tangent 4x, because sine divided by cosine is tangent. Okay, great. Doing some very simple example for integration. For example, I need to integrate something very simple, 4 to the power x dx. How you remember? This means 1 over natural log from base your function, this means natural log 4, multiplied by exponential function 4 power x and plus c. This is all example illustrate our theorems. Now doing something similar for your homework. For example, number 52. Number 52 from your book. I'm showing in the lecture, I'm showing some even numbers. Homework you usually have it's odd numbers, and it will be help you make it homework. Okay, your function here is natural log with base 2 third root from 2x plus 1. And here we need found derivative. Before we start, we little bit simplify our function. This means root like coefficient go to power root like coefficient go to in the front. This means I have 1/3 natural log, log with base 2 from 2x plus 1. Now I don't have any roots. This means found derivative will be much easier. Okay, derivative now equal 1/3 like coefficient stay here. Natural log with base 2. This means I have 1 over natural log 2. Then I have fraction who is denominator is 2x plus 1 because inside log we have 2x plus 1, and derivative 2x plus 1 is will be 2. We're done. A little bit right is better way. This means I have 2 over 2x plus 1 times 3 ln 2. This is my final answer. Okay. One more question. 76, for example. Here we need integrate x plus 4 6 to the power x plus 4 square dx. We can see we have substitution, whereas x plus 4 square we substitute some new variable. Let's go, it will be u. Then twice x plus 4 dx, it will be du. And use this substitution, our integral will be easy. Rewrite like 6 power u du. It's equal exponential function integral. We have 1/2 1 over ln 6 to the power u plus c. Or go back, we have 6 to the power x plus 4 square over twice natural logarithm 6 plus c. Okay. One more example for integration. Number 80. Let's go. I have integral from -4 to 4, 3 to the power x over 4 dx. Here we have in some coefficient for x. This means this is linear combination x, and we need to remember our theorem I'm showing you. This means 1 over this coefficient x, it will be in the front. 1 over 1/4 will be 4. And then we use our formula how it will be same 3x to the over 4. And here we need divide by ln 3. And we need plugging from -4 to 4 equal. Well, I think coefficient 4 over ln 3. I go to out, and then 3 power 4 over 4, it means 1, 3, minus 3 power -4 over 4, it will be -1, this means 1/3, 3 power. It will be 4 over ln 3 multiplied by 8/3, or finally we have 32 over 3 times ln third. That's it. All about what I want to tell you, all about section 5.5. Doing your homework, and if you have question, ask me, please. Okay, good.